Hello my dear students, welcome to this session now. Last session I stopped the problem here, okay. I think you have noted down already. Let's solve this problem to find V1, V2 and power of each source, okay. Now look at this problem. Using mesh analysis, how many equations you are getting? 3. Using node analysis, 1, 2, 3, 4. Don't come to conclusion 4 minus 1 because there are two ideal voltage sources without any series resistor. Definitely n number of nodes, n minus 1 equations. That condition fails here. Okay. Now, if you take this one 0, you already know this is 10 volts. Yes or no? This is V1, this is V2. It is forming a super node. Look at this. But if you change the reference node position from here to here, for example here, okay, then it becomes what? 5 volts. If this becomes reference node, then this will become what? A principal node now. You don't have more than one reference node in the given network, only one reference node, right? If you take this one as a reference node, this becomes what? 5 volt. And now this becomes V1, this becomes V2. Again it is forming a super node. Yes or no? That means you're not escaping from the super node here in this problem. Yes or no, all of you? When you're not escaping from the super node, why should we shift the reference node? So let us do as it is given. 0, V1, V2, 10 volts. Okay. So minimum number of equations required to solve this network using node analysis 2, mesh analysis 3. Finally, the node analysis is the best method to solve this particular problem. Okay. So let me apply super node analysis here. V1 minus V2 is equal to 5. This is the first equation. And this is the super node forming here, right? Okay, you can replace it with a short circuit and draw that. I think you don't waste time. Directly you can attack the problem. V1 by 8. V1 minus 10 by 2. V2 by 6. V2 minus 10 by 4. Yes or no? This is the second equation. You solve these two equations and get the values of V1 and V2 values. Okay? You can solve them. Once you find V1, V2 values, then you can find anything that you want. Yes or no? Because he's asking the first question. V1, V2, of course, he's also asking. Okay? I0 and V0. Please note on this. V1, V2, I0, V0. Sometimes he doesn't mention V1, V2. He will directly ask you I0, V0. Hope you understand the point. Okay. In such cases, what you have to do? Anyway, you have to apply node analysis. Even if he's asking V1, V2 or not, okay, you're supposed to find V1, V2. Without V1, V2, you can't do anything. Now, what is I0? I0 is 10 minus V1 by 2. What is V0? 10 minus V2. Yes or no? 10 minus V2 will be giving you what? V0. That's it. You can substitute the values. First of all, you check here. Okay, V1 by 8, V1 minus 10 by 2, V2 by 6, V2 minus 10 by 4, right? Solving this 1 and 2, I can give you the answer directly here. V1 is 9.2, V2 is 4.2 volts. Now what do you get here? I0. 10 minus 9.2 by 2, that is 0.8 by 2.4 ampere. 10 minus V2, 10 minus 4.2, nothing but 5.8 volts. That's it. Okay, 5.8 volts. Then this is nothing but the first question, right? The first question you got it here. But the second question is the power. Power we need to find. What is the power actually you need to find? To find the power, you require current here, right? Yes or no? Power of 10 volts, let us say. Power of 10 volts. For that, you require current through 10 volts. Assume some current. Okay? You can ask me, sir, what is the direction? Random. Okay? Randomly, I'm picking up the current direction. Doesn't matter what will happen. I don't know. Okay? Let me apply KCL. Why KCL? Because there is no resistor. Apply KCL at this node. KCL at this node. KCL at node A. Ix is entering. Okay. 10 minus V1 by 2 leaving. 10 minus V2 by 4 leaving. Yes or no? 10 minus V1 by 2 leaving. 10 minus V2 by 4 leaving. 10 minus, what is V1? 9.2 by 2. 10 minus 4.2 by 4. Okay. 0.8 by 2. 5.8 by 4. Just get this value, 0.4 plus. What is that? 5.8 by 4. 5.8 by 4 you can get, I think all of you are having calculators. 5.8 by 4 will give you, okay, 1.45 plus 0.4, this is 1.85. This total one is 1.85. Understand? So what is the power of the 10 volts then? Power of 10 volts will give you 10 into 1.85, that is 18.5 watt. But what is that current doing actually here? Leaving from positive. So our assumption is correct actually here, okay, that we come to know at the end of finding the value because it is a positive value. So supplied power. Understand? Next, what about the current? Let us assume IY, because there is no resistor. You have to apply KCL. KCL at node B, let us apply. Either here or here you can apply, doesn't matter. But let me apply here. Okay. Power of 5 volts procedure. KCL at node B. IY is entering. IY is entering. V2 by 6 is leaving. Okay. V2 minus 10 by 4 is leaving. What is V2 actually here? 4.2. 4.2 by 6 plus 4.2 minus 10 by 8. Okay. So what is that value actually? 4.2 by 6. You get 0.7 plus 4.2 minus 10, okay, divided by 8, that is minus 0.725. So plus 0.7 will give you, okay, minus 0.025. I hope you understand the point. So V2 by 6 and V2 minus 10 by 4. So I think we did a mistake here, right? This is not 8, this is 4 actually. Okay. So please correct it, all of you, quickly. I think we did a mistake. This is not 8 actually. This is 4. So what is actually V2 minus 10 by 4? It is actually V2 minus. So 5.8 by 4 will give you 1.45. So minus 1.45. Okay. Minus 0.7. So minus 0.75 ampere. That's it. Okay. So what is the power of this particular element? So power of this 5 volts will be 5 into, you got negative value, that means your assumption is wrong. Okay, that means if you had taken the current direction reverse, you would have got, okay, you would have got positive value, that means. So therefore, minus 0.75, that is absorbed power according to the direction that we got absorbed power. Okay, so this is actually, you can write 3 by 4, right? So minus 15 by 4 absorbed power is nothing but plus 15 by 4 is supplied power. What is this? 3.75 watt. Note down this please, all of you, quickly. So one must be good at calculations, simplifications, should not do any silly mistakes. Make use of the calculator. And meanwhile, I just give you one more problem, seventh problem. Classroom workbook, question number 7. Now let's deal with dependent source problems. Okay, find Vx value. Find Vx. Okay, so let me take this off. I think all of you are done with this, right? Okay, let me erase it. Please note on that question once again. It is there in your classroom workbook, question number 7. Okay, so let's find the value of Vx in that problem. Okay. Vx value. Dependent source problems, you must be little careful. And most of the problems are given in the exam are dependent source problems only. Okay. In what way we should be careful, that we'll observe here. Okay. So first we apply mesh analysis, then we go for node analysis. Okay. Both the methods will apply and we'll understand how we are going to get it. How many loops are there? One loop. How many equations you are supposed to get? Only one equation, right? Let's see what is happening here. So -1 into I, minus 2Vx, minus 5 into I, minus 2 into I, plus 15 is equal to what? 0. But after writing this equation, we understand that there are two variables, Vx as well as I. Yes or no? To solve that equation, definitely we require another equation. Yes or no, all of you? See, there is only one loop. We need only one equation, strictly speaking. But because of the dependent source, because of this dependent variable Vx, yes, there is a possibility of extra equations requirement. There is a possibility for what? Extra equations requirement. That is why you must be careful. That extra equation can be obtained usually by Ohm's law, KCL, KVL, current division or voltage division. There are only 5 ways you have. Okay, Ohm's law, current division, voltage division, KCL, KVL. Using any one of these based on the situation, based on the problem given, you can obtain that extra equation. Understand? So what is that extra equation? Tell me. Now I think you understand clearly. This is Vx. The current flowing here is I. I think you can relate. Okay. Because of this I current downward, that also give you plus minus. Then you can take Vx is equal to, what is that? Plus 5I. This is second equation. This is first equation. Now solving these two equations here, 1 and 2, you get value of Vx. Understand all of you? This is one way. There is a possibility for extra equations requirement. There is a possibility for the requirement of extra equations. Understand? Okay. Now, node analysis. For example, if you go with the node analysis, let us see what is happening. Suppose if you take this one 0, you directly get this what? Vx. Yes or no? Now let us write the equation here, Vx. Now the node variable and the dependent variable both are same. Yes or no? Node variable and dependent variable. Here in the previous case, The loop variable and the dependent variable both are different. When loop variable, dependent variable are different, you observe that you required extra equation. Yes or no? Now, if the node variable and dependent variable both are same, so you don't need an extra equation. You look at that. Look at that. Vx by 5 plus Vx plus 2Vx minus 15 by, yes or no? This entire path, you look at this. Vx plus 2Vx minus 15 by 1 plus 2, that is 3. 3 is equal to 0. From this, you see, you have only one equation and one variable, you can directly find it. You understand, all of you? I don't say always you need extra equations, but I would say there is a possibility for extra equations requirement, okay, in the case of dependent source problem, depending on the problem given, okay. So you need to find Vx value here, and I can give you the answer directly here. 4.1667 volt, and here also 4.1667 volt. This is the answer you are going to get. So please note down this. So what is the conclusion? Dependent source problems, there is a possibility for extra equations requirement in case of dependent source problem. Understand? Question number 8. Please note on that. Question number 8. Classroom workbook. Question number 8. Okay. Now, here is asking find V naught. Please note down quickly. Find V naught. I think I can remove this part. Please note on that. Now let us see the solution here. Mesh analysis will give you two equations plus one more dependent variable will give you three equations. Let us not go with that. Okay. Now node analysis will give you 1, 2, out of 2, 1 is reference, therefore this is going to be V, but already V naught is also another variable. Here the node variable and dependent variable both are different, therefore definitely you require extra equation. Okay. Now look at this. First we write normal equations, then we look at the extra equation. Okay. V minus 4V naught by 5 plus V minus 3 by, yes, this path. Look at this. There is source, right? V minus 3 by 1. Then V by 5. Extra equation you require, right? How do you get that extra equation? How these two elements are connected? Series. What is the total voltage available here? V, yes or no? The voltage between these 2 points is V. This is 0. This is V. Nothing but the voltage between these 2 points is also V. Now these two are connected in series. Can't we apply voltage division rule for this particular portion, having known the voltage across them? Yes, we can do. V naught is equal to, you can write, V naught, 2 by 2 plus 3 plus 2 by 2 plus 3 into V. But the division is taking place like this. Yes or no? The division is taking place like this. Plus minus, then plus minus, plus minus. These are the actual polarities. But how you want the polarities, desired polarities minus plus. Mismatch is there. Therefore, put minus sign before that value. Then now you solve these two equations. Solving equation 1 and 2, you get the value of V0. Please do that. You get the value of V0. Okay, that is minus 0.6976 you are supposed to get. Okay, you get V value, that is 1 point. Okay, 1 point. I'll just give you, looking at that answer here, 1.744. Okay, please solve these two. It's a simple one. You can solve them. 1.744. So he's asking this one, what is V0 value? Next, classroom workbook, question number 9. Please note down that all of you. I think all of you understand how to solve. Okay, using. Okay, in the case of dependent source problem, how to solve it. Okay, using node analysis is the best method for this particular problem. Node out mesh analysis is the best method. Problem number 9. This is another interesting problem. I 10 volt, 2 ohm, 4 ohm, 3 ohm, 6 ohm. Okay, he's asking to find a V1, V2, V3. Okay, V1, V2, V3. Find V1, V2 and V3. This is the question, right? Okay. Okay, so I think you're done with this, right? So now look at that problem. What do you have? How many loops are there? Mesh analysis will give you 1, 2, 3. Okay, here the current I is given here. Okay, because dependent variable must be shown, otherwise you can't solve the problem. Okay, insufficient data it looks like if I is not given. Now, if you go for mesh analysis, 1, 2, 3, 3 equations, right? Okay, and if you go for node analysis, 1, 2, 3, 4. Okay, 1, 2, 3, 4. But before you conclude 4 minus 1, check there are 2 ideal voltage sources without any series resistors. That is an advantage for you. So 4 nodes, 4 minus 1, 3 equations don't come to such conclusion without cross-checking whether there are any ideal voltage sources without any series resistors. Now you have 2 sources without any series resistors, right? So let me now choose this particular node as 0. Actually, he is asking V1, V2, V3 by taking the 0. Let us put it aside for a moment. We'll come back to that later. Our focus must be always on how to solve the network with less number of equations, so that we take less amount of time to solve that network. Okay. So let me take this 0. Then what will happen here? This is 10 volt. This becomes what? 5 into I. I think this is the only node which is left now where we do not know the voltage. That is V, let us say. Okay. So what do you get now? V minus 10 by 2. Equation please. V by 4. V minus 5I by 3 is equal to 0. This is the first equation because I do not know I here, right? V and I both are there. Therefore, let me find this I. I is equal to what? 10 minus V by 2. 10 minus V by 2. Second equation. I told you that extra equation is required. In case of dependent source problems, you may require extra equation. That's a very, very important point to be noted. Understand all of you? In case of dependent source problems, okay, extra equations might be required. What is extra equations? You already understand the meaning of it. N number of nodes, n minus 1 equations, plus some extra equations might be required because of the dependent variable. Okay. Now let us solve this 1 and 2. Solving 1 and 2 here. Shall we go here? Okay. Solving 1 and 2. Please tell me what is V and what is I. Okay. Just solve it and tell the value. Okay. So let me give you the values here. 1.522 ampere current, and this one is, I'll give you the answer here. Okay. Please note down. You also cross check once again. 6.956 volts. Understand? After solving these two equations, equation 1 and 2, you get these two values. Now look at this. You need to answer the question what? Taking this node as a reference node, what is V1, V2, V3? So let me just draw it once. Actually, you have taken this is 0 and you got 10 volts, you got 5I and you got V, yes or no? This is how you solved actually. But what you want actually here, okay, this one should be 0, right? Okay. And if this is 0, this becomes what? V1 is equal to 10 minus V. Then V2 is equal to 0 minus V. Then V3 is equal to 5I minus V. Because if one node voltage is reduced by V, then every node voltage is reduced by V value, right? Therefore, finally you got the answer here. V1 is equal to 10 minus 6.956. Okay. V2 is equal to 0 minus 6.956. V3 is equal to 5I, okay, minus 6.956. 5 into, what is that, 1.522 minus 6.956. So you have to tell these values, but I just directly write here all the values here because I have got the answers with me. So all of you please cross check that by your own calculations. We are supposed to get the answer here 3.043. This is minus 6.956. And this is going to be 0.6522. Okay. This is how you are supposed to answer the questions. Okay. And hope you understand all this, right? Then meanwhile, question number 10. Classroom workbook. Do that, all of you. I think you have done that. Okay. Now next problem, please note down. 10th problem. Find I1, I2 and I3. Find I1, I2, I3. Okay. So let's solve this problem. Of course, in the exam, he will ask you either I1 or I2 or I3. Or else sometimes what is the power of 20 volts? What is the power of this 10 I naught dependent source? Okay. Like that, he may ask you some questions. Okay. So definitely not all the quantities because it's a time taking process. But for practice sake, let's find all these quantities and we'll get some experience how to solve that network. Okay. Now make an attempt here. Which one do you prefer, mesh analysis or node analysis? Which one do you prefer, mesh analysis or node analysis? Mesh analysis, if we go 1, 2, 3 loops, so 3 equations you get. Yes or no? And you cannot say, sir, please let us apply mesh analysis because mesh currents are given. We can go for mesh analysis. Not like that. Mesh currents can be determined even from node analysis also. What is a mesh current? Is it not a branch current somewhere else? Definitely you can find that current. Okay, using node analysis also. Therefore, don't worry about that. Okay, because they have given here the branch current doesn't mean loop current doesn't mean that you always go for mesh analysis. Let us sincerely apply our technique, that which is the best method. Identify now using node analysis 1, 2, 3 and 4. But if you take this one as 0, then this voltage is going to be what? 20 volt. And this voltage is going to be what? Minus 10 I naught. And this is the node voltage which you do not know. I think one variable is enough. Plus I naught is there because there is a dependent variable. In case of dependent source problems, you may require extra equation, right? That you can do. Okay. So therefore, finally, how many equations you require if you go for node analysis? Okay, one equation plus one extra, totally 2 equations you require. Now let us solve it. Taking that bottom node as a reference node, because here there are 2 voltage sources without any series resistor. Okay, that is an advantage for us. If you take this is 0, this is 0, you can immediately define this is minus 10 I naught. You can immediately define this is 20 volts. Understand? Okay. And you do not know the voltage, you can take V. Okay. Now let us apply. V minus 20 by 4. V minus of minus plus 10 I naught by 8. V by 2 is equal to 0. Equation 1. You do not know I naught, right? Let's find that I naught. One more variable is here. Let's find that I naught here. I think you understand 20 minus 10 I naught. Okay, these two are the 2 voltages. I think potential difference is known here. Therefore, I naught can be written as 20 minus of minus plus 10 I naught by, what is this? 6. Okay. Luckily, in this particular context, without even looking at this particular equation, you are able to find I naught because this entire equation is in terms of I naught. So let's find this I naught here. So what do you get here? I naught 1 minus 10 by 6, right? If I take common, 20 by 6. I naught 6 minus 10 by 6, 20 by 6. Cancel. And this is actually 4 minus 4. 4 5 jar. So I naught will become what? Minus 5 ampere. What is actually V value? what do you get V value here? So if you substitute this in this particular equation, okay, I naught is equal to minus 5 ampere. In equation 1, if you substitute, you get V value. Yes or no? So once you get V value, then later we'll think about what is I1, what is I2, what is I3. But in fact, in this context, I3 is same as what? I naught. Yes or no? Okay. But what is V value actually here? V value you get here, okay, 12.857 volts. This is the V value. Once you substitute here, you will come to know that. But I naught is equal to what? Minus 5 ampere. Okay. Now let us look at I1 and I2 values. How do you find I1 and I2 values actually here? What is I1? Loop current. Somewhere it is going to be branch current, right? Where is it going to be branch current? Tell me. The branch current is same as loop current. Okay. In which element? Actually, it is going to be an element which belongs to only that particular loop. Now you tell me which element belongs to only the first loop. Tell me. 20 volt. Yes or no? Now tell me which element belongs to only second loop in this context. 10 I naught. Therefore, I1 is flowing. Here the branch current is same as loop current I1. Here I2 is flowing. Here the branch current is same as loop current I2. Yes or no? An element which belongs to only that particular loop, that carries the branch current same as loop current. That's the concept we know already very well in the mesh analysis. We discussed elaboratedly, right? Now let us find this I1. Find the current I1. How you find current through any path again? If that path consists of a resistor, we apply Ohm's law. Otherwise, we go for KCL. This path doesn't have any resistor. Let us apply KCL. Node A. Here also, there is no path resistor. Okay, node B. Let us apply KCL in this node. Okay, first we apply KCL at node A. KCL at node A. Okay, so I1 is entering. I1 is entering. I naught is leaving. Plus 20 minus V by 4 is also leaving. Yes or no? 20 minus V by 4 is leaving. I naught is leaving. I1 is entering. So what is I naught? You know very well, minus 5 plus 20 minus 12.857 by 4. You get this. Similarly, KCL at node B. If you apply here, I2 is leaving. I naught is entering. I naught is entering. Yes or no? V minus of minus plus 10 I naught by 8 is entering. V minus of minus plus 10 I naught by 8 is entering. So substitute here minus 5 plus 12.857 plus 10 into minus 5 by 8. Okay, just find this value. And already I3 is nothing but, I naught is nothing but minus 5 ampere. Okay, just note down this and also calculate them. Also calculate them. This is going to be minus 9.642 ampere, and this is going to be, you can minus 3.214 ampere. Okay, so please check the answers once again. You can also calculate. You can go with all these calculations. Okay. Now we'll look at another problem here. I think all of you done with this, right? Okay. So what is V value you got? All of you got the same value V. Substitute this I naught here and you get the value of. Please quickly do that. Another problem I'm giving here. Question number 11. Question number 11. Please note down classroom workbook. Question number 11. This is very simple, easy problem. Find V naught. Right? Find V naught. Find V naught. This is very simple problem. Okay. Now it's a time to apply our experience to solve the problem here, right? So look at that problem. Okay. Look at this problem. Yeah. Now, if you go for mesh analysis, how many equations you require? 3 minus 1, 2 equations required. If you go for node analysis, how many equations required? 1, 2, 3. 3 minus 1, 2 equations required. So minimum number of equations required to solve this network. If that is a question given to you, what is your answer? 2. And both the methods are giving 2 equations. But when you got an opportunity to solve it, you can utilize certain opportunities like, current source with a parallel resistor can be transformed into voltage source with a series resistor. Then all these elements will become series. In that case, I think these 2 nodes are enough. Then 1 equation is enough to solve it. Yes or no? So applying source transformation is something like this. Minus plus. I'm not drawing the rest of the part, okay? Already you have this so and so here, plus minus. I'm not drawing it. But just, whenever you got this opportunity, apply source transformation. But without drawing this network, you are supposed to solve this network. But still, I'm drawing here for this only this particular part. Taking this is 0. Directly, can I take V naught? Yes or no? Directly, I can take V naught? Yes or no? Now, tell me. Source transformation and inspection, if you apply both at a time, then 1 by 4, 1 by 8, 1 by 2 plus 1. After transformation, the resulting network will be in series. Yes or no? So 2 plus 1, 1 by 3 is equal to minus 20 by 8. Now, after transformation, what is this voltage source value? 2 into 5, 10 volts. Already it is 40 volts. So touching positive first, therefore plus 10 plus 40 by 3. Why 3? Because these 2 are in series. Okay. Then if you simplify this, you get the value of V naught. Do that. Okay. So I think you understand now, wherever you get an opportunity, you should not miss it, particularly source transformation. Understand? Okay. So do that and tell me the answer. What you got here? Tell me the answer. Here. You're supposed to get 20 volts. Okay. So this is how you can solve, my dear students. I stop the session here and we'll see the next, the other problems in the next session. We'll continue the next session.